Good day, guys. This is your tutor engineer. Today we are continuing with our series on algebra. Today we'll be doing a straight line function. So let's start with the first question. Underline the correct answer of the options given below, given between brackets 5.1.1. The line x is equals to 4 and x is equals to minus 4 are perpendicular or parallel to each other. So you have to choose between perpendicular or parallel. Okay, let's first start by visualizing, because when you're dealing with mathematics, it's actually a science of visualizing. So let's plot a line x equals to 4. The line will be like that, and then x is equals to minus 4. We'll cut vertically at minus 4. So basically these lines are parallel. As you can see, they're not perpendicular. So we're going to underline here parallel as the correct answer. So let's go to the next question. The next question says the equation of the horizontal line through the point P, which is 3 and minus 2, is x is equal to 3 or y is equal to minus 2. Okay, before we answer that question, let's just wrap off the previous question. Okay, then let's go on to answer. So basically, let's first start by plotting point P. We've been given the coordinates for point P, so it shouldn't be difficult to plot. So 3 is our x coordinate there, and then we've got y. So point P should be here, somewhere here, and then you've got 3 here, then you've got minus 2 there. So that's going to be point P. So we're going to draw a horizontal line across point P. The horizontal line will go like that. So the equation of that line is actually y is equals to minus 2. So we're going to underline y is equal to minus 2. There's the answer. Now let's go to question 3, 5.2. Okay, before we go to 5.2, let's wrap off the previous question's answer. And then 5.2 says on the set of axes below, draw and label the graphs defined by y is equal to minus 2x plus 1 and y is equal to x minus 2. So okay, let's start by plotting this graph here. Okay, so when you plot a straight line function, you have to identify the y-intercept. That is when, remember, x is 0. So when x is 0 for this graph, we're going to have y is equal to 2 times 0, and then y is equals to 1. So our y-intercept is going to be 0 and 1. So the x-intercept is when y is equals to 0. So we're going to say y is equal to 0, then you're going to have 2x plus 1. Then taking 2x to the left hand side is going to be positive. Then you're going to find x is equal to 1 over 2. So the x-intercept is going to be 1 over 2 and 0. So basically, we're going to plot these 2 points onto our graphs, and then we're going to join them in a straight line. So let's start with the first one, where x is 0, y is 1. It's a point here. Then when x is half and then y is 0, the point is somewhere there. So let's join the 2 points with a straight line. So it's going to be working out as something like this. So you can even put the arrow to say it's continuing this way and the other way. and label it as y is equal to minus 2x plus 1. Okay, we're done with the graph, the first straight line graph. Now let's do the second one. Y is equal to x minus 2. So the y-intercept is when x is 0. So we're going to say when x is 0, then y is equal to minus 2. We're going to have the first coordinate 0 and minus 2. And then the x-intercept likewise is when y is equal to 0. We're going to have when y is equal to 0, we're going to have 0 is equal to x minus 2. Then x here will become 2. Then the x-intercept is going to be 2 and 0. So likewise, you can plot these 2 points on the graph. Let's start with the one on top, 0 and minus 2. So x is 0, y is minus 2, it's a point there. When x is 2, then y is 0, the point is going to be here. Then let's join the 2 points with a straight line. Okay, straight line is going west, it's going east. Okay, yeah, something like that. And this side, you can just put an arrow here and label your graph as y is equal to x minus 2. So this is how you draw a straight line function. I hope you understood that part. So let's move on to the next question, 5.3. So 5.3 says points A, B, D are given below. Then the first question is find the equation of the line passing through points A and D. Okay, so basically we have to find the equation of the line that is passing through 2 points. Okay, we are given A and D, so these are the 2 points you're going to be dealing with. So the first thing to tackle is to write the general equation of a straight line. So we're going to first calculate the m, then you're going to calculate the c. The m is the gradient. So when you calculate the m, it's actually easy. Between A and D, we're just gonna say the gradient is equals to the y at point D minus the y at point A divided by the y at the x, at point D minus the x at point A. That's the equation of the gradient. So the y at point D is 0. So you're going to say 0 minus the y at point A is 4. 0 minus 4 divided by the x at point D is 5. 5 minus the x at point A is 1. There's a 1 there. 1. So our gradient is going to be minus 4 on top divided by 4 at the bottom, which is just minus 1. Okay, so now we have our graph is we're going to replace m with minus 1, so you're going to have y is equal to minus x plus c. So we can use any point to calculate the c, whether we use point D or we use point A. So let's use point D. Okay, point D has y equals to 0. And then you're going to have x is equals to 5 plus c. Then we can work out the c from here. So c is going to be 5 here. So c is equals to 5. Right, so you can complete our graph and say now, to answer question 5.3.1, you can complete our equation and say y is equal to minus x plus 5. That's the answer. So that's going to be the equation. And then let's go to 5.3.2. If A, B, C, D is a parallelogram, give the coordinates of point C. Okay, so remember there's an extra component that has been added which we have not been given. They say A, B, C is a parallelogram. So here you would say C would be somewhere there, right, for it to be a parallelogram. So let's just use a black pen so that you don't confuse. So C is going to be somewhere here for it to be a parallelogram. So let's just let's draw that parallelogram, because when you're dealing with mathematics, it's better to formulate a picture. So a picture is formulated best in drawings. So parallelogram is when all the opposing sides are parallel. So it's something like that. So the question is, we must calculate the coordinate of C. So how are we going to calculate the coordinate of C? Okay, we know between point A and point D, the distance between them is 4. Let me show you why am I saying so. So the coordinate, the x-coordinate of A is 1, and then the x-coordinate of D is 5. So the distance between 1 and 5 is 4. So we're going to use that very same knowledge to calculate the coordinate of C. So if you can take that knowledge and apply it for point B to say what is the distance, if you add the distance of 4 from point B, then we're going to get to coordinates of C. So it should be true also for the distance between B and C, which is going to be 4 as well. So basically the x-coordinate for C, you're going to say minus 1 plus 4, right? So minus 1 plus 4 is going to give us the x-coordinate of 3, right? So that the distance between C and B is also 4. So I hope you understood that part. That's how we work out that's how we're going to work out the x-coordinate for C. Then going to the y-coordinate for C, you're going to also say point A and D, they have a vertical distance. They've got a vertical distance. Let's just mark it with a green color. So A and D, they've got a vertical distance of, okay, the y-coordinate for D is 0, and then the y-coordinate for A is 4. So also the distance between A and D vertically is 4. So even here we're going to apply the very same knowledge to say the distance between point B and point C is also 4, and then you can work out the coordinate of C. So let's just add, we're going to say here now, because we know that the y-coordinate for point B is minus 2, so we're just going to say minus 2 minus 4 will take us to point C. So minus 2 and minus 4 gives us minus 6. So that is how you work out the coordinate for C. So to write here the full answer, for coordinate of C, just gonna say 3 minus 6. Okay, so that's it for question 5.3.2. I hope you understood it. Now let's go to 5.3.3. It says, what is the length in units of line AB? Okay, now we need to calculate the length of line AB. So which color are we going to use for that? Let's use a red to calculate length of AB. First, let's write the equation to calculate the length given the coordinates. The equation is AB is equals to, it's going to be the x at A minus the x at B, then all of that squared, then you're going to say plus the y at A minus the y at B squared, all of that under the square root. That's the formula we're going to use for the distance. So now we're going to continue to say AB is therefore equals to, the x coordinate at A is 1, so you say 1 here, minus the x coordinate at B is minus 1. So let's just replace minus 1. Then we're going to say all squared. Don't forget the square. Then the y coordinate at A is 4. Then minus the y coordinate at B, which is minus 2. So let's write a minus 2 there. We're going to say squared. So continue to say AB. Okay, remember all of that is under a square root. So basically here in this bracket, you're going to have 1 plus 1 squared plus, in the other bracket, you're going to have 4 plus 2 squared, and then you put the square root. Then AB is going to be 2 squared plus 6 squared, right? And then AB is going to be 4 plus 36 all square root. Don't forget the square root. Then now we have AB is equal to the square root of 40 units. So basically you can also simplify this to say AB is 40 is the same as 4 times 10 square root, and say AB, the square root of 4 we know it's 2, then the square root of 10 you can just leave it as that, so, and say the answer is 2 square root 10. That's the answer. So here you can write the answer as AB is equal to 2 square root 10 units. So we've come to the end of our today's lesson. Stay tuned for the next part on graphs. On the next lesson, we'll be discussing other forms of graphs, hyperbolas, parabolas, and so on and so forth. So stay tuned for the upcoming lesson. If you like my video, don't forget to subscribe. So until we meet again next time, cheers.